In today's video, we will talk about crystallographic axis, axial angle, and crystallographic notation. In any crystal, crystallographic axes are imaginary axes on the basis of which crystal system of crystal is decided. These are imaginary axes, not real axes, which decide the crystal system of any crystal. And the parameters which decide crystal system include are the relative length of the crystallographic axis and the angle between various crystallographic axes. And this angle between the crystallographic axes are called axial angles. Suppose in general we have three crystallographic axes A, B and C. A is from front to back, B is from right to left and C is from top to bottom. And angle between A and B is gamma and angle between B and C is alpha and angle between A and C is beta. In case of hexagonal and trigonal system there are four axes. And Euler's formula which says face plus solid angle is equal to h plus 2. Crystallographic notation. These are the methods used for expressing intercepts of a crystal face, and they show relation between the crystal faces and the crystallographic axis. And, and any point where crystal faces cut the crystallographic axis are the intercepts. We have two systems. The first system is the parameter system of weiss. Intercepts are parameters only. Parameters of a crystal face are written along with the notation of the crystallographic axis in weiss system. For example, if a face cuts a axis at unit distance, b axis at distance of 2 units and lies parallel to c axis, then its parameters are written as a to b infinite c. So this is the crystal face. If we extend, it will cut a axis, cut b axis, but it will remain parallel to c axis. This is the parameter system of weiss. And then the index system of Miller. In Miller indices of a face consist of series of whole numbers derived from parameters by taking their reciprocal and clearing fraction. So it is the series of whole numbers which are derived from parameters by first taking their reciprocal and then clearing all the fractions. And it is always written in axial order A, B and C. For example, we have face PQR. We have face PQR, which cuts positive ends of crystallographic axis, and its parameters can be written as 3a, 3b and 2c. And so for converting it into Miller indices, first letters are omitted and parameters are written as 3, 3, 2. And then we will take reciprocal of these parameters 1 by 3, 1 by 3, 1 by 2. Then fractions are cleared by taking LCM and Here in this case it is 6. Fractions are clear now, and we get a Miller symbol for the phase PQR, which is 223. And here are some important points about this Miller system. For phases that intersect negative ends of the crystallographic axis, a bar is placed, example 223 bar, which indicates this phase intercepts C axis on the negative end. And if intercepts are parallel to axis, it means that it cut that axis at infinity. For example, intercepts or phase are 1 infinite infinite. It means it cuts B and C axis at infinity. Then its Miller indices are written as 1 naught naught. We represent 0 as naught naught naught, and Miller symbol, which is not bracketed, it strictly denotes a single phase. 1 naught naught here represents only a single phase of the crystal, and bracketed symbol represent all the phases of a form. Bracket 1 naught naught, it represents all the phases of a crystal form. And general formula or symbol, not formula, symbol for a phase that cuts all axes at different lengths is HKL, and for hexagonal and trigonal system it is HKIL because they have 4 axes. Meaning of this indices is that it is are the set of parallel planes HKL that cuts A axis into H parts, B axis into K parts, and C axis into L parts. The HKL are the set of parallel planes. It denotes the set of parallel planes which cuts A axis into H parts, B axis into K parts, and C axis into L parts. So we end the video here. Thank you.